So dear students, we were solving this problem. A special kind of rigid body is given to us. The cross section is a regular hexagon. The moment of inertia is given to us, and that body is rolling down the inclined plane. We need to find the ratio omega initial to omega final. So dear students, you must have solved the problem. First of all, here is the final result. The final result is 17/11 you must have found. Dear students, let us have focus on it. This figure shows the situation right before the rigid body hits point A. A and B are the points on the inclined plane. Right before hitting the point A, this is the situation, and right after hitting the point A, this is the situation. What is the difference? Here it is pure rotation about point B, and here it is pure rotation about point A. This is what is the situation in pure rolling without slipping. In this case, initial angular momentum of the rigid body about point A is this. How we have written this term? By combining two terms. One is IC omega and the other term is M VC are perpendicular. So L initial is I1 omega I plus M A omega I times A by 2. What is A omega I? A omega I is velocity of center of mass, and perpendicular distance is R by 2. Right after hitting point A, pure rotation about point A, so angular momentum about point A is what? I2 omega. This omega is omega final, and this was omega initial. So conservation of angular momentum about point A, because the torque about point A is 0. So I2 omega F equals omega I times I1 plus M A square by 2. This is initial angular momentum equals final angular momentum. This gives us omega I by omega F equal to this. I2 and I1 are given to us in the problem, right? So this ratio comes 17/11. Dear students, you must have got your All India rank. Keep working hard to improve your All India rank and work on the time management so that you can do well in boards as well as JEE Main as well as in JEE Advanced. Good wishes.